our last topic for our class will be, we're gonna test the hypothesis for the difference of two means, and these means are what we call this dependent samples, all right? These two means are coming from two dependent samples, and some of these are what we call, the requirement is for them to be dependent samples that they have to be matched pairs design, right? So typical for this case will be a pre-test, post-test, okay? So the same set of students will be taking a pre-test, and then after a certain intervention, either that be learning intervention or teaching intervention, they're gonna have a post-test and seeing what the result of the grades will be in terms of achievement score or whatever they're trying to measure as a parameter. Okay, so let's read in here first what we mean by step number 0. What are the certain criteria to be satisfied in order to use this method for hypothesis testing for the difference of two means. All right, Brett, can you see it from here? Thank you.
Random sampling, independent sample values, matched pairs design, normally distributed, and n is greater than or equal to 30.
Thank you, right? So either, again, by central limit theorem, if you see that the sample size is more than 30, then you can assume a normally distributed sample distribution. However, even if it's less than 30 as a sample size, as long as they guarantee and they specify that that sample came from a normally distributed population, then we can assume normal distribution as well, okay? So let's follow those step 0 for answering in here number 3. All right, let's read this number 3 and see how we can work on this one, okay? Angelina, go ahead please. Yeah, in problems 3 and 4.
In problems 3 and 4, assume that the differences are normally distributed.
Thank you. Okay, letter A, what do we do?
Determine let's say D1.
DI, yeah.
DI equals xi minus yi for each pair of data.
Thank you. All right, so that's our step 1. Determine DI, that is xi minus ii for each pair of data. So that means in here, DI, that means that's the what? The sample mean difference. Okay, so this is a sample mean difference. So in short, simply subtract each of them and you're gonna get the xi, yi. Be cool? Right? With that being said, let's read now our let's say in here. So what's that gonna be? For example, for D6, for the 6th data set, what is your D6 equal to? So basically, D6 will just be what? 6.6 minus 9.0. Okay, so which means, how much is that gonna be? 6.6 minus 9.0 in your calculator. What is it? Negative 2.4. Which means that y value in there is 2.4 more than x1 or x6. Okay, questions, guys. Next, actually this is not sample mean difference. This is just basically sample difference, right? Now if you go to D hat, let's read that one in here for letter B, okay? Brittany, what did it say in here?
Compute the sample difference in the
SD, right? So the D hat is the sample, that's the mean sample difference, okay? Yeah. So again, the DI are the sample differences of each of those values. Now D hat is the mean of the sample differences, and if you say SD, then that is the what? The sample, what's this? Standard deviation. Questions, guys? So let us do that one first and see our calculator and how we can work on that. Okay, so if we follow the steps in our calculator, StatCrunch, we're using StatCrunch for this. So how do we do this? So here it is. Here is the data set. So if I were you, you can go to chapter 11. That is 11-2-3, right? 11.2, practice number 3. And if you click in there, you're gonna see this data set. Is it the same as our data set? Guys, is it the same as our data set? Verify. Okay, 7.6, 7.6, 7.4, 8.1, 6.6, 10.7. And the sample size is 7. As you may notice, even if the sample size is small, if it is specified that this came from a normally distributed population, then we can assume normal distribution for this sample, even if the sample size is small. Questions? So, what do we do? It says in here, let's click on stat. Okay. Now, after clicking on stat, we're going to what? T, stats. Okay, because we are talking about mean, okay, quantitative variable for parameter. And we're gonna go to, this one is what? Paired. Okay, why is this paired? Because we are using matched pairs. Recall that we are using matched pairs design, so I'm gonna click on the paired for such. Here it is. And then from there, sample 1 is on what column? In here, sample 1 is on the X column. That's the second column. Okay. Sample 2 is the Y column. That's the third column. Okay. Questions with what we did so far? Once again, let me just exit out just to review what we did. Okay. I went to stats. I went to where? T, stats. We're going to do test statistic for population mean. Now, this is a matched pairs design, so it's neither one sample, two sample. It is a paired sample. Again, these are dependent samples, so we're going to click on paired. On the sample 1, I'm going to click on X. On sample 2, I'm going to click on Y. Okay. After that, what do we do? In here, we're gonna click on, well, we can save on the differences, and we put in our hypothesis, all right? So what's our hypothesis? Null hypothesis will always tell us that what? That the mean difference should be always equal to what? If there is no difference between the first and the second sample, then that means the difference should be what? Guys, null. That means if there is no difference between the first and the second sample in terms of their values, then that means their mean difference should be how much? 0. Very good. Okay. So that means everything in here is based from that. That the mean difference is always going to be 0, right? If there is no difference at all. That's the null hypothesis. Now, for the left-tailed, what's that going to be? What inequality should we use? Left-tailed? Less than, very good. Two-tailed definitely is what? Not equal to 0, right? And right-tailed will definitely be greater than 0. So as you may notice in here, everything is based on 0, because 0 means that the null hypothesis, there is no difference in terms of values of the first and the second samples, okay? Anyway, or sample values. So in that case, what does it say on number 3 a while ago? If we go back to the problem in number 3, it says, what's what test are we considering? Left-tailed, right-tailed, or two-tailed? Left-tailed, because that's less than. And your alpha, or level of significance, is given to be 0.05. Okay, so again, it's a left-tailed test with 0.05 level of significance. Okay, so let's go back and see how we can do that one in here. So UD equals 0 as null hypothesis. I'm gonna change this alternative to what? Less than 0. And I'm gonna click on, oops, where is that? Here we go. I'm gonna click on the show critical value at a significance level of 0.05. Okay, what else do we need to do? Well, basically that's it. And then we can click on this p-value plot, summary statistics. So maybe we can See that summary statistics, because typically the summary statistics will give us the means, the standard deviations, and everything else that we need. You can see in here some other details like histogram if you need it, dot plot, box plot, QQ plot, some of those. Anyway, let's click in here, compute, and see what we got from our end. Okay, so here it is. Just put this in here. Okay, here it is. And answering our questions a while ago, first of all, what is your D hat? What is the mean sample difference equal to? Negative 1.61, right? So the mean sample difference, bless you, is negative 1.61, all right, 614. So again, that is the mean sample difference, okay? And that is basically from your calculator. If you want to compute for the test statistics manually, that D hat is that negative 1.614, okay? Minus 0, why is it 0? Because 0 is the null hypothesis, that there is no difference, right? That's why there is 0. All over SD, what's your SD? What's the standard deviation in here? You see any standard deviation for this one? Let's click on the other one. So as you may notice in here, we have the standard deviation for the X, and we have the standard deviation for the Y. We also have the sample mean for the X value, oops, and also the sample mean for the Y value, okay? Go. The degree of freedom is equal to 6, simply because how many samples do we have? What's the sample size?
7.
You only have 7 sample size, less 1, right? Then that's gonna be 6, okay? Now, what's our t-score? Our t-score is turned out to be what? Negative, oh well, the t statistics, right? This is the test statistic, T0 or test statistic, equal to how much? That is negative 2.23. Alright, so with that being said, and since this is left-tailed, we compare this to the T critical value at alpha equals 0.05 and degree freedom equal to 6, and it turned out to be what? Negative 1.94. Now, how do we compare the T statistics and T critical value? Guys, look at this one. Is negative 2.23, is that less than or greater than negative 1.94? Less than. Very good, right? So as you may notice in here, that is less than negative 1.94. And with that being said, okay, if you look in here, guys, left tail. Again, we are looking at a left tail test because that's less than 0. A set value equal to 0.05. And we see in here that your test statistic is less than negative T at alpha, right? Left tail. So what can we say for our conclusion or interpretation? Should we reject the null hypothesis or should we not reject the null hypothesis? Is this true? That the test statistic negative 2.23, is it less than negative 1.614? Yes, it is, right? In that case, what is our conclusion then? Should we reject or not reject the null hypothesis? Reject the null hypothesis, right? So very good with that one. Also, you can compare that one with the p-value, right? So as you may notice in here, so either compare the t-stats or the p. So the p-value that we got is how much? 0.0336. Now you compare that one to your alpha value, which is how much? 0.05. And what can you say about the p-value and the 0.05? Is it less or more?
Less.
Is it less? Yeah, it is less. Thank you. With that being said, it's on the left tail end, outside of the confidence interval. With that being said, so yes, we reject the null hypothesis. And what is our interpretation of that one? That there is sufficient evidence to support the alternative hypothesis. That there is a what? A significant difference. Actually, the significant difference is what? Less. Okay? Less than 0. Questions with our conclusion for that? And we can see in here as well, in our data set. Okay, if I erase this one, you would notice in here our data set as well. Okay, for such questions. So once again, since our p-value 0.03 is less than 0.05, our alpha set, then we reject the null hypothesis. Also, since our t-stats is negative 2.23, it's less than negative 1.94, alpha 0.05, df equals 6, then yes, we reject null hypothesis. Questions?